Please wait for a minute. Keep it on. Okay, thank you all.
Thank you, Rishikesh. Thank you, Sai Balaji Education Society. Thank you. Convey my thanks to Dr. Anamika ma'am, please. Thank you all participants.
Yes. Brijmohan sir, can you hear me?
Yes, sir, I can hear you.
Okay. Now I request Lembe sir to please introduce Brijmohan sir.
Somehow my camera in my laptop is not activated. I don't know, either it is from setting side or, but I have logged in into my mobile also. So you can see my, yeah.
Yes, sir. Now I request Lembe sir to please introduce Brijmohan sir.
Sir, you are on mute.
Sir, unmute yourself. Lembe sir.
Good afternoon to everyone. On behalf of Sai Balaji Education Society and Organizing Committee of AICTE ATAL Faculty Development Program, it's my privilege and honor to warmly welcome our distinguished guest speaker for today's online session, Mr. Brijmohan Sharma. Mr. Brijmohan Sharma is a renowned corporate planner and transformational leader with over 25 years of excellence in the leadership, development, motivational empowerment, competency enhancement of soft skills, creative thinking, and aptitude development. He has trained and inspired more than 50,000 corporates and students, shaping professionals across diverse domains. He is currently a Senior Assistant Vice President, Account Management and Service Delivery at EXL Service, a global multinational firm headquartered in New York. He also serves as a National Council multinational firm headquartered. He is also served as a National Council member at ISTD, reflecting the significant contribution to India's learning and development ecosystem. His strong academic foundation, BTech from NIT Raipur, PG Diploma from SIBM Pune, Training and Development from ISTD New Delhi, and MPM from Pune University, combined with his rich industry experience, make him a truly versatile expert. His leadership roles across ITI, Data, Test Funda, PIBM, Calibre, Mindware, Career Forum, and Arijat Software Solutions reflect a career built on the innovation, performance, and thought leadership. Today, we are privileged to have him speak on a highly relevant and futuristic theme, leveraging Industry 4.0 technologies for the smart manufacturing. Its highlights will help us to understand how digital transformation, automation, and intelligence technologies are redefining the future of the manufacturing industrial growth. Before we begin session, on behalf of Sai Balaji Education Society and entire ATAL FDP team, it gives me an immense pleasure to offer our felicitations to you, sir, as a token of respect and gratitude for accepting our invitation and gracing this program with your expertise.
Thank you, sir. Rishikesh, sir, I am audible?
Yes, sir. So
Yes,
we
sir,
are truly honored to have you with us today. With this, I warmly invite Mr. Brijmohan Mishra to address the gathering and take the session forward. Thank you, sir.
Thank you very much, sir. Thanks for welcoming, and I'm privileged, I'm honored to be in this August gathering. I have been into the different profiles, but I believe addressing professors and mentors is really always a challenge for anyone. And I believe I'll try to come up to your expectation. But if there is any anything anybody wants to add, so that will be always welcome, because I always believe that any session when we are joining in such gathering or such event, it is always a learning experience for us. So let me share my screen. Just a minute. So is my screen visible to everyone?
Yes, sir.
Great. So let me start with the session. Today I have been given a topic which is very relevant in today's scenario, leveraging Industry 4.0 technologies for smart manufacturing under ATAL Online Faculty Development Program. So let me start with the session overview. In today's session, in first half, in 1.5 hours, I'll try to cover the importance and concepts and theme about the topic which is given to me, which will cover in general understanding of Industry 4.0, then evaluation and context related to this topic, followed by core technologies which are generally used under this concept, and then smart manufacturing, concept of smart manufacturing and real world applications. And finally, in second session, we will be covering academic preparation, means how academia can leverage, utilize this whole concept to create and generate a workforce to which can compete and which can work with synchronization with this concept of Industry 4.0. So let's move forward with the Industry 4.0. But I think before going to Industry 4.0, we must understand what exactly is Industrial Revolution. So basically in Industrial Revolution, if we go back to history, we can see that there were major changes in and transition in manufacturing and industrial process with new innovative technologies. So actually this goes beyond 300 years, almost 300 years back, when this industrial revolution started, which we generally call as Industry 1.0. So that started precisely in 17th century, late 17th century. And actually that was the time when mechanization powered by water and steam engine revolutionized textile manufacturing and transportation. So basically in those time in Industry 1.0, mechanization was primarily used in textile industry, and means a little bit in mobility, we can say in transportation, followed by Industry 2.0, which was started in late 1800. And that was the time when electricity was invented, and it enabled mass production through assembly line, and then it started transforming manufacturing efficiency as well. That again goes almost for 100 years, and then started Industry 3.0, which was basically induction of electronic and IT, information technology, and that brought automation and programmable logic along with controller and computerized system, which were embedded and which were applied in manufacturing and industry, and revolutionized the whole industrial process. That again actually could not stay for long, and taken over by Industry 4.0, which started generally in 2011. We can say 2011 was the year when it was started in Germany. Actually, if we talk about Industry 4.0, it was the process, or it was the period time when means things were various technologies were connected at enterprise level, and production facilities was connected with AI driven, and then self-optimized factories. All these things came into existence, and the total situation were changed. So let's move forward to understand why Industry 4.0 matters today. If we see in today's market demand, it is hyper competitive. It is globalized. You cannot work in isolation. So we are working in global market, which requires manufacturer to continuously innovate and optimize operations. And that is required to maintain their competitive edge. If you are not in competition, if you are not producing best quality of services, best quality of product, and definitely then you will be out of competition. So basically, the mass customization and shorter product life cycle started demanding flexible, responsive production system, and that can adapt quickly to changing customer needs. Means we can very well connect ourselves or remember 20-25 years back. Means those were the time when we, or maybe you can go back to 50 years before. When our parents used to purchase something, okay, that was the time when the product was used for year after year. If it is not working, then you go to repair shop and getting it repaired and using it for years and years. But today is the time when you purchase a product, if it is not working, so 50% or maybe 70% of the time we simply throw out or change the product or machine, and we get something new. And the best part is when we are purchasing something new, we get a better product with better features and sometime in less price. Okay. So this is the time the way demand is increasing, and the demand is coming from customer basically. So we can say that the need was basically driven by three major areas, or you can say points. First was productivity and efficiency. So that was actually needed to maximizing the output while minimizing the waste and resource consumption. Okay. Second was the data-driven decisions. We can use all kind of data which is collected related to our manufacturing, related to our product, our services, our business. We can leverage those data in real time, and we can make intelligent business strategies and decisions. Okay. And third point was sustainabilities and goals. So optimizing energy, because today is the time when everybody is talking about sustainable process, sustainable product. So sustainable ecosystem, in fact, rather it is better if we say sustainable ecosystem. Okay. So because resources are limited, and we have to ensure that whatever resource we are using, either it is energy or it is let's say water or anything, we have to assure that we are using in those things very judiciously, so that we can optimize our cost, we can maximize our product, and in that way we can be in the competition. So I'll take a pause over here. If anybody has any point, any input, that is welcome. Otherwise, we'll move next. Okay, so no point, no question. So let's move to a next point, which I would like to actually see the definition. Means we need to understand what exactly is Industry 4.0. So basically, when we moved from Industry 3.0, that was the time when invention in electronics, in computers, in data, actually they started taking place. So in Industry 4.0, it merges digital and physical system to create intelligent and connected manufacturing process. So which enables real-time data. Whatever data we have, we can means we can collect data. We can find data from some other source. So we can use those real-time data for smart automation and self-learning system across the value chain we can create. And then we can integrate human and machine, their collaboration to remain crucial with human guiding strategic decision. So actually when human, machine, and then the complete ecosystem is integrated in such a way that we move toward a complete automation process where sometime even it means 1% human interaction is not needed sometime. Okay, so that is how we can define Industry 4.0. So basically when we talk about Industry 4.0, as we discussed, that means it connects machine and system inside the factory, means these are connected. For example, let's take one example. Okay, suppose one machine is down. That machine can inform to some other machine or some other system or the operator that this machine is down. Okay, so what will be the next step? And then it is also possible that the machine which is down can communicate to the other machine automatically, means that can be started automatically, and that the machine which is in the spare, it start automatically and it can start production. Okay, so or it can be ready for the production. Okay, or sometime it is also possible that one machine is its production capacity is limited, and if we do require more production, okay, so it can communicate to other machine, okay, for more production, so that we can match the additional requirement. So this is not only possible that we are these two machines are communicating in the same premise or same setup, but it is also possible that two machines are geographically located in two different places and they are communicating. Okay, they can communicate with their operator. So this is the way how Industry 4.0 is changing the whole ecosystem. Okay, also in Industry 4.0, multiple machines can be interconnected, okay, to synchronize the production. If there is any additional demand, one factory can inform the other factory to increase the production, and vice versa. Okay, if demand is reduced, so two factories can can connect, which are connected, can communicate, and they can reduce the production, so that they can reduce the stock. So basically, when we talk about this Industry 4.0, we can say that a new phase in the industrial revolution that introduces intelligent networking of machines and process, means both. One is networking of machine, and this is for the process, means we are trying to make the process intelligent, okay, for the industry with the help of information and communication technology. So this is very important to understand, that we are using information and communication technology to automate whole ecosystem of production, to make it more means we can optimize our resource and more profitable. We can make our business more competitive and profitable. So in short, in nutshell, we can say Industry 4.0 is basically a concept of connecting physical world with the digital world. Okay, we can use computer, we can use different devices, we can use machines, or these are connected to communicate with each other to make decision without human intervention. Okay, and this is to optimize all existing digital technologies actually to next advanced level. So basically, this is how we can define Industry 4.0. So is there any question over here? I can take a pause for 10 seconds. Okay, so let's move to next point. What are main pillar of Industry 4.0. Okay. So before going for next pillar, let's try to again understand that what are the basic concepts which are used in Industry 4.0 to make it more realistic for the real world actually. So as we discussed in the our discussion, that this is actually giving us a connected ecosystem which is providing us real-time visibility of process, production, everything. Okay, then it is also possible that AI powered system which are we can say automated one can take intelligent decision without human interaction, and they can adjust parameters and they can adjust the workflow dynamically to maintain optimal performance. Then next is predictive maintenance. We can always see the possibility of predictive maintenance so that we can avoid the downtime of our industry or our machine. Okay. And the objective of this is to make the zero downtime goal, because if your machine is down, your factory is down, so it is loss of business. Okay, so idea is to achieve zero downtime. So that is the most important thing. And then enhanced sustainability. So we spoke about sustainability. That is again in today's era, sustainability is something which is very, very important. So basically there are 8 pillars I can say which actually drives Industry 4.0. So let's talk these 4 pillars one by one. So the first is cyber and physical system. Okay, so when we say cyber physical system, basically let me try to explain this point. Okay, CPS, generally in short form we call it CPS. So CPS are integrated system where physical processes are tightly connected with digital computation and communication. Okay, and these systems are using they can use sensors, they can use different softwares, they can use different intelligent controller to monitor and interact with the physical world in real time. Okay, so CPS forms the backbone of modern automation in any factory and plays a crucial role in Industry 4.0 for smart manufacturing. Okay, let me take a very simple and common example. Okay, suppose we have a autonomous vehicle which uses sensor, cameras and AI algorithm to detect obstacle. So if it sees any obstacle, okay, it can make decision and navigate safely just to avoid the collision. Okay, another example we can take, like we generally use smart grids where digital systems monitor electricity uses and balance energy distribution efficiently. So we see that today the consumption of electricity, distribution of electricity, so they are using a smart grid. If in one place the consumption is less, so the grid will divert the load to other side. Okay, so in this way all these things are monitored and balanced by automated system. Okay, another example I can take is like we can take medical devices. Now we all know that we are robots are actually performing operations, okay, surgeries. So medical devices such as smart pacemaker we are using that continuously collect patient data and adjust heart rhythm automatically. Okay, so there are embedded systems which are using all these things. Okay, collecting data and then processing the data and taking the decision. Okay, what should be the heart rate based on this these data which is available on real time. Okay, so and again very common thing is in manufacturing we have seen robotics, then assembly line equipped with real-time data sensor to adjust production. Okay, to adjust consumption of material. Okay, or speed up or tool path to maintain quality. So all these things are automated with the help of robotic assembly line. Okay, So these examples shows how CPS improves accuracy, safety. Safety is another very important part, which we will again further discuss, and efficiency across various industry. So cyber physical system is means one of the backbone, we can say, in this industry 4.0. Next thing, which is very, very important, is Internet of Things, IoTs. Okay, so we can define Internet of Things as a network of physical objects that are able to collect data with the help of sensors and then exchange data each other with the help of internet. So basically a device is there and which is collecting some data, and it is transmitting data to some other place. It is storing data to some other place or within the system itself. Okay. Let's take an example of IoTs, means regular, means our general regular life, day-to-day life example. We use nowadays smartwatches, and you must have seen that smartwatches are equipped with various means applications. One of the application is like to means monitor your health status. Okay, so in a smartwatch, what happens? It detects, suppose we are talking about body temperature. It detects body temperature. It may detect blood pressure or heartbeat. If it finds any of these things abnormal, it informs you, means there will be some beep. It can ask to book doctor's appointment, means if you say yes, it is quite possible if you have integrated your system to any of the means app which is related to any hospital. So it may directly connect to the hospital for booking the doctor appointment. It may directly connect with the hospital system to book any of the test which is required in that particular physical means condition, health condition, without any human interaction, with the help of AI and machine learning. So this is one of the very common example, very real life example which we are seeing on our day-to-day life. Okay, so in short, we can say that IoT is a network of physical objects that are able to collect data with the help of various sensors, devices, and exchange data each other with the help of internet. Okay, it means IoTs help devices to interact and communicate. Okay, there may be one device, there may be two or more than two devices, so they can communicate with each other without any human interaction. Okay, if required, that can be always done, but the system is so equipped and so means designed that it can it works automatically. Okay, so next point is our day-to-day life, what we are using is, and one of the pillar is AI and machine learning. So if we talk about AI, the use of AI in our industry 4.0, first let's try to understand what is artificial intelligence. Okay, by definition, we can say AI is a computer program actually, which enables a machine to simulate human behavior like learning, planning, maybe resourcing. Okay, and then using the knowledge or knowledge sharing and problem solving, etc. So basically these are the functions which generally we can use with the help of artificial intelligence. Okay, and then means obviously there are machine learning. So basically means with the human brain we can design a machine in such a way that it can process data and it can use the data for means intelligent decision making. So one of the means best example, we can say any robot which is working. Okay, so robot is basically we are using robotics and then artificial intelligence with machine learning. Okay, to create an intelligent robot basically. Okay, so AI algorithm basically supports in industry how we are using AI algorithm. So actually it support predictive maintenance. That is one of the major area where we are using in industry 4.0. And then actually that predictive maintenance means we are anticipating means if there is any possible machine failure, so we can avoid, we can go for means servicing and all means without any downtime. Then AI algorithm also uses process optimization, okay, just to adjust parameters dynamically, means for any process in any machine. It can be used for quality inspection. Okay, so we can use computer vision to detect identification or means any defect. So quality inspection can be done, and then we can also use for means autonomous robotics for repetitive tasks. So means AI or artificial intelligence with machine learning can use robotics to means perform those tasks which are repetitive and that needs minimum human interaction. Okay, so actually AI and ML driven insight in Industry 4.0 is very important to reduce waste, improve cycle time, and increase reliability. So I'll take a pause for 10 seconds. If you have any question, you have any input, you are welcome. Okay, so next
no points. You can go ahead.
Yeah, okay. So let's move to next point, which is the next pillar, which we call cloud computing. So by definition, cloud computing is basically use of remote server to store, to manage, to process data, which can be accessed through the internet on demand from anywhere. Okay, so actually it is stored in cloud or any server in the cloud. Okay, and means it can be used for any decision making. Okay, so basically this cloud system provides us scalable means data storage and advanced analytics. Okay, because means the kind of data which is flowing, okay, means that is from multiple system, means we are receiving data, means visual data, we are receiving text data, video data, audio data. So various types of data are created by various devices. Okay, so all these data can be stored and then means in the raw form, and then we can use these data with the help of machine learning and AI to make decision. Okay, intelligent decision basically, so that we can means reduce latency and we can improve reliability in our manufacturing control applications. Okay, next point is robotics and automation. So in robotics and automation, again, we have discussed that robots are basically a programmable machine. They are nothing but machine. Okay, and that are usually able to carry out a series of action, means whatever is programmed embedded in the system, so they can carry out the series of program, and they can means complete actions which are means advised in terms of software program autonomously or in semi-autonomously, means both the things are possible. Okay, so robotics is again branch of technology which deals with physical robot. Okay, and collaboration with means human and robot is means very useful. Okay, for any technology means scenario. So when we are using advanced robotics, so basically we can program these robot machines, these robots in such a way that they are usually able to carry out a series of action automatically, simultaneously. Okay, so this branch means robotics when we are using in Industry 4.0. Okay, in terms of technology, so we are dealing with the means to interact means with the machine which is integrated with the robot. It is also possible that there are multiple robots, means we can means interconnect multiple robots. They can interact with each other. They can interact with human being. Okay, and they can means we can ensure that the work is means completed safely. Means there may be some scenario where means it is difficult to means work for human being. Okay, suppose scenario where means high temperature, high pressure means atmosphere is there. So we can use robot in those scenarios, those conditions, okay, to perform those duties. So That is very important. That means in hazardous places or in precision oriented operation, we can use robots very efficiently. Okay. And as we discussed, robot always complement human workers by assisting them in assembly line, in packaging, and in inspection. Okay, just fostering a means human-centered smart factory, just to means maximize the production and means optimize the resources. Okay, both time, energy, and resource. So this is really interesting for robots. Now we can talk about digital twins. Generally we call that what we call virtual reality and augmented reality. Okay, so this is again another pillar in Industry 4.0. So if we talk about augmented reality, augmented reality is nothing but technology that create enhanced version of real world in front of uh, you by adding a layer of digital transformation on that. In the other side, virtual reality is complete virtual. There is nothing real. Means virtual reality is nothing but anything which is virtually created, which does not actually exist in the real world. Okay, so this is very important to understand the difference between these two, and how where you are using this means AI means virtual reality and augmented reality. So basically, we can use these things for operators training, our training and development process. We can means use this for example, maintenance guidance. We can use in ergonomics design, and then remote collaboration also we can use this. Okay, so basically when we are using augmented reality, it enhances workforce capability by overlaying digital information onto physical environment. Okay, so generally we call them as digital twins. Then next we come about advanced analytics. Okay, so advanced analytics is related to basically data analytics and big data. Okay, when we talk about big data, so big data is nothing but it's a process of storing and examining large volume of data from various sources and systematically extract useful information from that. As in earlier we discussed that data is coming and we are receiving data from various sources. Okay, so big data is the process of means this analysis and then making the predictive modeling for actionable business intelligence. Okay, we know means when we are working in means industry, that means there are multiple devices which are connected together. Okay, and they are generating and transmitting data continuously, means there is no stop. Okay, in this process, huge volume of data is actually processed and received. Okay, and this is stored in a remotely located server. Okay, which we called as cloud. Okay, so actually this whole process is part of big data. Okay, as we discussed, means this data can be means in the form of text, it can be in form of images, voice, videos. Okay, so this large volume of data needs to be analyzed and extracted. Okay, to convert into useful information. So means until data you are using it for useful information, it is of no use. Okay, and we all know that this sentence or this quote is very famous in today's era, that data is the new fuel. Okay, so if you want to means excel in your business, you have to use data intelligently, okay, and smartly. And this process, actually we call this process as data analytics. So in means Industry 4.0, in short, means we can say that big data analytics is a process of storing, then examining large volume of data from various sources, and then systematically extracting useful information. Okay, from those data. Okay, and then last pillar, eighth pillar, which we generally means call is additive manufacturing. Okay, so in a simple word, we can say additive manufacturing is nothing but 3D printing technologies. Means one example, 3D printing technologies, which actually is enabling rapid prototyping, okay, and customizing production. So same thing you can produce again and again, okay, with the very same parameter, with the same quality and same. So when we say additive manufacturing, actually this word we can define as it's a computer controlled process. Additive manufacturing is nothing but computer controlled process that creates three-dimensional object by depositing materials and then means creating an object. Okay, usually in layers. So they deposit material in layers and they create an object. Okay, so basically this technology enables rapid prototyping, custom tooling we can say, and low batch production of complex geometries also we can produce. Okay. Because of the use of this, we can reduce material waste and shorten our development cycle. Okay, by aligning with agile manufacturing needs. So it is not always necessary that we are manufacturing each and everything which is designed and instructed to the machine, but it is also possible that we can create our production in an agile method. Okay, so that is something which is very interesting related to additive manufacturing. So here I'll take a pause for 10 seconds. If you have any question, you can, or if you have any input, you can share. Otherwise, we will move to the next. Next point is industrial. Let's talk IIoT in detail, actually, because that is to be understood in detail. So how we are using IIoT in Industry 4.0, which is transforming our manufacturing through connectivity. Basically, we are connecting various devices through internet, through Wi-Fi, and means it is creating a network of intelligent sensor devices that continuously collect and transmit data from every corner of the manufacturing operation. So basically, when we talk about IoT, there are four aspect which is to be understand. Okay, one is sensor and connectivity. Okay, so smart sensors we can use in various machines which are embedded in equipment. Okay, to monitor various things like temperature, vibration, pressure, and performance metrics. Okay, then it is also useful for real-time monitoring. So live dashboard, display operational data display. Okay, can be enabled just for the immediate visibility into the production status and efficiency. Then remote diagnosis is possible with the help of IoT. So basically, technicians can troubleshoot and resolve issues from anywhere, reducing response time and travel cost. Okay, so one of the very simple example, if you see, we all use I'm telling you a simple example. If we are using laptops and suppose we have any problem in our laptop, so we call our IT department, IT team, that I am getting so and so problem. They connect, they take control of our device, and then they work from remotely and we get our problem resolved. Okay, we use broadband connection, our Wi-Fi device is there. Suppose it is not working, we complain to the service provider, and then they give some instruction remotely. They do some a software update or something, and then device start working. So all these examples are actually example of IoTs. And then of course energy insight must be there. Okay, how much energy is controlled, means consumed, and then means tracking and identifying for the optimization process. So that means our overall cost is reduced. Cost of production or cost of service should be reduced. So this is detailed understanding of IoT. Let's try to understand cyber physical system also, CPS also, little bit in more detail. Okay, so as we know that this is nothing but seamless integration of physical process with computational intelligence. Okay, so there are core components
Sir, I think you are on mute.
Hello,
Excuse me,
Brijmohan
sir.
sir,
Yes.
you're not audible. Please wait. Brijmohan sir, you're not. We are not able to hear
Okay.
you. Just a minute.
Okay, I think from system somebody muted everyone or what?
Yes, sir.
Am
Yes.
I
Now
audible
you can
now?
be able to. Yes. Now your camera is also active, sir. We can see
Okay,
you.
my camera is also active.
Yes,
Okay.
sir. Yes.
Okay, so but my presentation is not visible right now.
Yes. Please
Let me.
share the PPT. Your screen is
Yes.
visible. Means the screen of Teams is visible. And now the PPTs are also visible.
Just a moment. How come it automatically? I am unable to. Yeah. Am I audible now, sir? Hello?
Yes,
Yes,
sir.
sir,
You
you're
are
audible,
audible.
sir.
Okay. And is my presentation visible?
No, sir. Your PPT is not. Please click on that slide.
Yes, sir. Now
Yes,
your
We
presentation.
can be able to see
yes, I
the
think it is.
Teams.
Yes,
We
yes, I
can be able
think
to see the
it is
Teams.
visible. Okay. So yes, I think it is visible,
Now
right?
PPT. Yes, yes, yes.
And I
Please
am
go
audible
ahead.
also, right? Okay. Thanks. So next is means how let's try to understand how industry 4.0 is technology transforming our manufacturing process. Okay. So basically means in industry 4.0 we are exploiting digital transformation by and revolutionizing our production facilities worldwide through intelligent system. Okay. And using data driven manufacturing basically. Okay, so in this process we are definitely using means one of the most important aspect is robotics and automation. Okay, so basically when we talk about robotics, robots and automation, this is all about increasing our speed, increasing precision, and last but not the least, or one of the most important aspect, okay, working condition. In our working condition we are means avoiding any accident. So safety is one of the major area where means these robots and automation is working really like a magic. Okay, so next point which we discussed earlier also a little bit is additive manufacturing. So there also we discussed about this additive manufacturing is nothing but when we require means rapid prototyping, we are means we require mass customization, or we are looking for lightweight component, means anything can be there. So all these things are means possible in volume with speed with the help of additive manufacturing actually. Okay, next let's see how we are using our cloud and data servers for the means use of this industry 4.0. So basically when we talk about cloud, as we discussed earlier also, that in modern manufacturing system, okay, we have to leverage distributed computing architecture. Okay, we cannot work in means isolation. Okay, So in this process, massive data volume means we are using while maintaining real time, and means we are providing responses, okay, from one system to other system. So this cloud-based system is basically working like a means blood vessels, or just to means execute our manufacturing system, making it accessible from anywhere. At enterprise level, we can make our resource well planned, okay, with global visibility. Means it is not about means we are working in one place in one geography, okay. We can see that what is the demand in global level, or how means our business is responding or performing in global level. So based on that, we can always take decision, and based on our data. So in that way, cloud is really working like very important aspect of means Industry 4.0. And then that is supported by, as we discussed earlier, big data, advanced analytics, okay. So basically, big data is playing vital role in data collection. Then providing us visual dashboard. Means we can create dashboard using various software like Power BI, Tableau, okay, and different other software. Means we can create a dashboard which is responsive dashboard, we can say. Means with the change of every fraction of second, we can see that how a business is, or production line is, or means our inventory, logistics is at which condition or which stage. All these things are available in the dashboard. So this is only possible when we are using big data and data analytics efficiently and effectively, okay. Digital twin technology I have already discussed in detail earlier also. So let's talk one more very important aspect, which is blockchain technology. Okay, in today's market scenario, blockchain technology is something which is really very important. Okay, so basically with the help of this, we can create trust and transparency in our supply chain system. Okay, so if we are using this technology, each and every step of movement of logistic can be tracked. Okay, if there is any change in any process, any system, any product, or any service, that can be identified, that who and why who has made the change, or why the change has been made. Okay, all these things can be collected. These information can be collected if we are using blockchain technology. So basically, blockchain technology provide us secure traceability, okay, and then anti-counterfeit protection that provides, and smart contracts also. So this is something really important for Industry 4.0. So now let's move to how this all these 8 pillars which we discussed, they are transforming our business, okay, in a smart workflow. Okay, so how actually they are adding, contributing value in our whole process. So basically, one aspect is data collection. With the help of data, means we are creating, by analyzing the data, we are making some decision. Okay, and decision is made, and then action is taken, and finally we are providing the service, or creating the product. So this whole transmission is conducted or used, or using a secure network, so that it is also secure from the any risk related to either from outside or inside. Okay, so we can create this secure network with the help of all these 8 pillars, and we can make our manufacturing in our Industry 4.0 very smart. Actually, we can say a smart manufacturing workflow. Okay, so next, let's move to before moving to next point, again I'll take a 10-second pause. If any question, any point, any input anybody want to say, I'm open for it. So let's now move to means Industry 4.0 hardcore, what exactly it is. Okay, so let's talk about key features and principles. So when we say Industry 4.0, so there are generally we talk about 6 features. One is interoperability. So that is nothing but we are using various system, devices, people, and sensors.
I think sir got disconnected. Please wait. We can take a 10 minutes break and we will join. Sir is joining. Meanwhile, I will request all of you to please turn on your cameras so that we can click a photograph. Everyone, please turn on your cameras. I need this for the record purpose, so kindly please turn on your cameras. Request everyone, please turn on your cameras. Okay, thank you.
आपने भी लिखवाया था विश्लेषण
Hello, am I audible?
Yes, sir. We have taken a 10 minutes break. So after that, we
Okay.
can start.
Okay.
So, so we can reach,
Okay.
you can
Okay,
rejoin
thank
by in 10 minutes, sir. Yes, yes.